In 1961, a meteorologist named Edward Lorenz was running an early computer simulation of the weather. To save time, he restarted one of the runs halfway through by typing in the numbers from a printout. But the printout was rounded. It showed 3 decimal places where the computer had been using 6. A change out in the 4th decimal, a difference smaller than a puff of air. And the forecast that came out the other side was completely, utterly different. Lorenz had just stumbled onto the reason we cannot predict the weather, and he gave it a name, the butterfly effect. Here's what he did next. Lorenz stripped the weather down to its bare bones, just 3 simple equations, describing warm air rising and cooling. 3 numbers, looping through 3 little rules, over and over and over. That's the whole thing. No randomness, completely deterministic, simple enough to scribble on a napkin. And then he just let it run and watched where those 3 numbers would go. So let's start 2 of these simulations almost identically, with a tiny nudge out in the 4th decimal, exactly like Lorenz's printout. For a while, they trace the very same path, right on top of each other. Then they start to peel apart, and then they're gone, wandering off in completely different directions with nothing in common anymore. That microscopic difference has exploded into total disagreement. This is why a 10-day weather forecast is basically a guess. In a chaotic system, to see far into the future, you'd have to know the present with impossible precision. The flap of a butterfly's wings really could tip next month's storm. But now comes the part that is genuinely beautiful. Take that endlessly wandering path and plot it out in 3 dimensions. It never repeats. It never crosses itself. It never settles down. And yet somehow, it never escapes. It stays trapped, forever, looping around inside this one shape. 2 great spirals, joined in the middle, like the wings of a butterfly. Mathematicians call it a strange attractor. The motion is pure chaos, but the chaos has a form. And that's the twist that closes out all of this chaos. The exact path is unpredictable. We can never say which wing it's on at a given instant or when it's going to jump across. But it is always, without fail, somewhere on those wings. So chaos, it turns out, isn't the absence of order. It's a deeper, stranger kind of order, unpredictable in every detail, and yet completely bound to a shape. We can't tell you where the weather is going, but we can show you the surface it's dancing on. So, that's round 25, and the end of 3 rounds lost to chaos. 3 times now, math has refused to hand us the future. The 3 bodies, the 2 rods, and now the weather itself. Brain, 0. Math, 24, round 25. Math takes it one more time, but this time it leaves us a gift. Not a prediction, but the shape of chaos itself. A butterfly you can never quite catch. Subscribe and stay curious.